Guys, so again, big thank you to Ted for doing this with us with the club tonight. Again, I'm a big DSD guy now, so well, I have been for many years. And as soon as I found out Ted agreed to do this 3 weeks ago, I asked him a bunch of questions on that first call, and he straightened me out in the error of my thoughts, which was pretty cool. So I'm going to get started then with the 5-question round, and then we'll let Ted take over from there. So question 1 for Ted, bear with me. So just give us a little bit about your history, what you did at Microsoft when you were there, if that's all right, and anything else, any stories or personal stuff that you wouldn't mind sharing with us?
Sure. I'd like to turn the question just a little.
Of course.
Because it's my past work history that's really enabled me to do this project. Okay. And they're pretty disjointed. I worked at Wang Laboratories for a while, and they were, software people drove everything, but it was a fun place to work. And then I worked at Cadnetics, which is an EE CAD/CAM company that lets you design circuit boards and lay them out. And one of my jobs there was low-level code and stuff, but another job was to actually work on the router. So that taught me how to do routing on circuit boards and stuff. Then I worked for a digital audio workstation company, which is where I met Gus Skinnis. And I was basically the main low-level code writer for their hard disk editor. And then I worked for a DSP-based hearing aid company, which let me learn a lot more about psychoacoustics and stuff like that, which is actually really important. Then the next thing I worked for was, a 3-man team. We were just taking somebody's thing and cutting the cost by a factor of 10 and making it run their software. And then I went to Microsoft, and I didn't do anything related to the DAC at Microsoft, but I learned a huge lesson. And this is slightly controversial, so I want to explain it just a little bit because it's important for how I do things. Microsoft, the biggest secret to Microsoft, and it's even written in books about Microsoft, is simple. They get feedback from the customer as soon as they can and use that to guide further development. They're not worried about getting rid of every bug, because getting rid of every bug means they're not getting customer feedback on everything. So they try to keep the number of bugs low enough that they don't lose money. And remember, anytime you call in to get support, it costs them like $300, and their profit is what, $30 on a sale. So they can't afford a lot of bugs. But what that taught me is it's very important to get what I have out into the field. I hate when I do release with a bug, but still getting people's feedback about if that's better, if that's worse, what other problems they'd like me to work on is much more important. And the PS Audio website really allows me to interact with people and get that feedback.
It worked for me. Cool. All right, on to question number 2. So I think you already touched on it, but I'll repeat the question anyways. So what led you into audio engineering, specifically the Sony DirectStream Digital and your prototype? I've
always been a musical kind of guy. I played trombone, clarinet, piano, organ. Not good on any of them, mind you. Sung in church choirs, barbershop quartets, other things like that in the Microtones, which is a group at Microsoft. And then, I took voice lessons for a while. And so all of these things really let me be able to really know if tonality is right or wrong on something. I mean, if you've been sitting in front of a timpani for 30 years, not literally, but you know what a timpani sounds like. In, what was it, 89? I went to an AES show, 92. And some friends of mine from the company I'd worked at, Waveframe, hauled me off to a room, and I didn't know what they were doing. Open up the door, and there's like Gus Skinnis, Andreas Koch, David Kawakami, and I knew some of them, but I didn't know what they were doing. And what they were doing is announcing multi-channel SACD. And, you know, they had these speakers that cost like $80,000 each. You know, there's 5 of them, and, you know, equally impressive amplifiers and everything else. But when they played the music, I never experienced music like that before. The surround was definitely part of it, but when they played Ubi Caritas, you know, it's recorded, you know, just press the record button and stand back in a huge cathedral. And I've sung Ubi Caritas in a huge cathedral, and it was just like being there. That was an epiphany for me, literally. It changed my life. I went home immediately and got a SCD 9000 ES, and I was hoping to heck that what I heard was DSD-ness, not what you get for astronomically expensive hardware. And it sounded wonderful. My daughter and I played music for 5 or 6 hours, and then when we put on a CD, it's like, ah! That I was under the misunderstanding that it was DSD-ness that was so much better than CD-ness. That's not quite true. DSD is a little better than CD when you have comparable equipment. I can definitely hear it. A lot of people can hear it. But just like there's a lot of people that are happy with MP3s, there's a lot of people that can't hear the difference between DSD and CDs, and that's just fine. Whatever makes them happy.
Well, and to get to your point there, Ted, it was the same thing. Like 20 years ago, I had one of those Universal players. I think I talked to you about this over the phone there. And it was just a little Sony Universal player. I had a Denon receiver hooked up to it and my homebrew speakers and all that. And I could hear the difference. Like the Elton John remasters that Gus did, you could clearly hear the difference on a crappy setup like that.
Yes.
You know, on the 2-channel stuff and even the 5-channel, right? And the CD version didn't sound the same.
Well, if you get a super bit mapped CD, correct. Sony did a lot of them, then the CD layer is mastered identically to the DSD layer because super bit mapping just does a literal translate, you know, of the bits down for CD. So then you won't be confused by the mastering. And then, just as we're going to get into later, an engineer that's really mostly attached to DSD, they're probably going to make the DSD part of their player as good as they can, but they're not going to spend quite as much time on the CD part of their player. And conversely, the universal players that were primarily DVD-A players, like from Denon, the DVD-A is what that engineer may really believe in, and they don't give as much work to the SACD. So, you know, some people had an experience that said DSD is better than CD, and some people had an experience that says, you know, CD and DVD-A is better than SACD. What you really need to do is, over a period of time, visit a whole lot of people, people that had like a Lin CD12 and a great SACD player, and you hear that the difference, they have the same tone, they have the same drive, but the CD is just a little more ephemeral than the SACD, a little more ghostly, not quite as stereo, which actually means a 3-dimensional image.
Understood.
And so SACD is just a little truer, but it's not like CD has glaring holes in it when played on a great player.
Yeah, I mean, again, like I was saying before, what you mentioned, like the player that I had basically took the SACD layer, dumbed it down to PCM. It might have been 24-bit 88 or even 24-bit 176. But again, what Gus told me last summer was a lot of that has to do with how it's mastered, exactly what you just talked about. So there we go.
Yeah, and something about that might be interesting to people is there are DVD-As and SACDs out there, like Linda Ronstadt's What's New,
yeah, I have it.
Gaucho, and a few of those others, and they sound essentially identical on a good DVD-A player and a good SACD player. They're mastered the same, so that takes out the mastering stuff. My opinion, I believe it, but I wouldn't try to convince everybody on the planet, is that a lot of masterers have a bias one way or the other. They like SACDs or they like DVDAs. So when they master, they'll pick the technology that they like the best and make it sound like what they think that technology sounds like. So almost all DVDAs have a lot more thump and bass and a lot more drive, and and SACDs, in my opinion at least, are often truer to the original sound. Mm. And those are just two different philosophies about how to master things, how to edit things, and, you know, how to record things. A lot of DVDAs are, you know, very heavily multi-mic'd. Mm. And on average, a lot of the multi-channel SACDs are much more simply mic'd. And that touches on one other thing, which is a lot of people think that you can't edit DSD, and that's not quite right. The DSD is like a slightly better tape. If you record to DSD and then play back, it is a little truer to the original than the tape. But by the time we get it edited and sent to us on discs and everything else, you don't quite have that same magic anymore. But my point is that the nicest way to do editing is to pretend like your DSD player is a tape player. When you want to do a bounce or a volume control or whatever, you play the DSD, then you use your analog console, do whatever the heck you want, any sound effects, you know, whatever, and then you record it back to DSD. And I think that's why some SACDs sound exceptionally good, is because it's back the way they used to master, you know, in the 40s and 50s, because mm-hmm. some of those are some of the finest recordings we have. And a lot of that isn't because they had the best equipment on the planet. It's because they took care to not mess with the sound. I wandered around. Go ahead.
Yeah, and again, one thing I noticed too, but not just SACDs, but even the DVD audio discs that I have, they're not part of the loudness wars from what I can hear. Whereas a lot of the CDs from the mid to late 90s, 2000s, they're just horrible. Like I've got the Eagles box set, and it's just nasty. I have to, mind you, through your DAC, it helps it a little bit, but it's just nasty sounding because I have to turn the volume down all the time on my old players and stuff.
Yeah, some of them are pretty horrible that way.
Yeah.
Things like replay gain and stuff can help a little, but you can't really uncompress it convincingly.
Cool. All right, sir. Let me go on to, okay, I want to, okay, so, sorry, go ahead, Ted.
You mentioned something.
Prototypes, yes. Show them off, please.
Something. This is the prototype for my DSD board. This is, you know, it's a monster.
That leads into the third question, which you know anyways, so.
And so I had started out building an SACD player. I built a little prototype and it didn't sound good. I built another one. It sounded worse. And I think, okay, I can't just keep spinning hardware. So a friend of mine had mentioned, you ought to use an FPGA. And so after a whole year of thinking about it, I realized I ought to use an FPGA. So I built this monster board. I didn't care how much it cost, and they cost a lot, you know, about $12,000 or $13,000 a piece. But I wanted to see if I knew what I was doing. Is this going to sound good? Because if it didn't sound good, I should go do something else. I was actually very surprised about how good it did sound. So I went and talked to various companies, see if they would be interested in manufacturing a cost-reduced version of it or whatever. You know, that wasted a couple of years doing that. My family lives in Durango, Colorado, so one time on a swing down to Durango, we thought, hey, Gus Skinnis lives in Boulder. Let's just drop by just for fun to say hi to Gus. And I mentioned that I was working on a thing and I had a prototype, and he asked to hear it, and he really liked it. So he said, you know Paul McGowan? I said, well, by name. He says, let me get him. He calls Paul on the phone, but it's date night for Paul. So Paul says, how about tomorrow morning? Paul comes back in the morning, and he was very impressed, but I think he was actually more impressed that I was using a laptop, going out USB to a USB to SPDIF converter, going over an RCA cable to a SPDIF to Toslink converter, and then into the DAC. And in Paul's world, Toslink sucks, USB sucks, laptops suck. He's changed his mind a little on some of those things, but he was just flabbergasted that through that daisy chain of crap that we were getting excellent sound. And in fact, he was so impressed, he took my wife and I back to PS Audio and introduced us to every single person that worked at PS Audio.
Wow.
He says, this guy built a fucking great DAC. And so we worked out a deal where they would manufacture, market, and sell them, and I would do the technical side. And that's worked out great.
Sounds great too, trust me. And like I said, we have a few DS owners in the club too, and I think they're online tonight. So, all right. So let me, Ted, by the way, cheers. You're allowed to have a drink while you talk.
Yeah, I just saw David say, yep, Paul tells the story differently. And indeed, he does tell the story differently. But Gus and I were there, and Paul is a very enthusiastic fellow, but a lot of times the story is what takes over in his head more so than the facts sometimes.
It's okay. Paul and Darren couldn't make it tonight, so it's all good. But again, what we talked about.
No, I think it's actually a feature for Paul.
Yeah.
It lets him see the 30-foot level, 30,000-foot level. It lets him get excited about things without getting into the details of whether they'll work well. And then he can just go tell the people in the company, please do this. And sometimes they tell him, no, that's stupid. But a lot of times it comes up to be just an off-the-wall product that works really well, like the noise harvester. You know, that's a weird-ass thing. It actually works for some people, so I can't say that it's bad.
But again, this is why I wanted the story to come from you when we were talking on the phone 2 weeks ago. So no, that's awesome. And oh, you didn't show off the, no, did you show off the FPGA board?
Well.
Oh, come on, might as well. It's
no.
There we go.
This is the prototype.
Yep.
And
right.
This is the FPGA. Let's see if I can aim it towards the camera.
Yeah, we see it. We see it. But and, you had this. You had a second board with you, I thought.
Oh, some of you may know that I'm working on an updated version of the DS at a higher price point. Paul will call it the cost no object board, but it's, you know, everything has a budget. But this is a very good board, and this is the current prototype of the analog board with Jensen transformers,
wow, and
stuff like that. And here's the digital board, which of course is a lot simpler because almost everything is in the FPGA. The beauty of this is it has two separate boxes, one for digital, one for analog. They're connected together with an optical link, and that allows you to not have ground loops in your system. You can have the digital box over by your computer or whatever you want, just away from your audio system, and have the analog up in your audio system. And that way you won't be getting digital hash into your system, even if it doesn't affect the DAC. In a lot of systems, it can affect the analog that's there. So we've got another round of this board coming. We always think it's going to be released in 3 or 4 months, but you know, that's been true for 2 years.
It's all right. It's all good. It'll be worth it. Okay, so then, okay, here we go. I think you may have covered this a little bit, but I'll just go over it again. So what makes DSD so analog-like in sound character?
Yeah.
That, and then I know you and I, when we went through the questions, that to kind of help a lot of the guys to, what's the difference between PCM and DSD?
Yeah, that's where I was heading with the answer to that question.
There, thank you.
A lot of people have misconceptions about a lot of this stuff. PCM is actually a very specific format, not what most people think it is. PCM says you've got a binary sample and there's a one-to-one linear map from that binary sample out to the level of audio you get. And it's sampled at a certain sample rate. Other things like MULA encoding it's a different format than PCM. There's also pulse width modulation and pulse density modulation. And the point is PCM not only says that it's a number of bits and a number of samples, but it says exactly what the value of every bit means. DSD seems like it's drastically different. It's 1 bit at a higher sample rate, but there's one other key thing to note is that it's noise shaped. A way of thinking about noise shaping is the RIAA curve for records. That's noise shaping, right?
Right.
It shifts the noise up to the high frequencies where you can't hear it as much, and therefore makes the low frequencies sound better. I don't know if you remember the earlier CDs, a lot of them had pre-emphasis.
Yes.
Noise shaping.
Mid-80s.
Shifts the noise up to the higher frequencies so they don't bother you as much.
Yep.
Of course, it sounds like crap if you don't play it back de-emphasized. But you take that noise shaping to the limit to make DSD work. I got ahead of myself, but in
It's okay.
PCM, the signal to noise ratio is roughly 6 dB per bit that you have. So 16 bits means that you have a signal to noise ratio down around 96 dB.
Correct.
And 20 bit means down around 120 dB, and 24 bit is down around 144 dB. What's interesting with, if you think of DSD as PCM, that's wrong, because then it would have a signal to noise ratio of 6 dB, which sucks.
Yep.
But the noise shaping takes all that noise that's down in the audio part of the band and shifts it up to the ultrasonic.
Correct. So
that you can filter it out easily later. So in fact, DSD is much more accurate than 24-bit PCM in the audio band. I'm not saying if you edit it 49 times, it's more accurate. And I'm not saying that editing in single rate DSD with every time you do an edit, taking it back to DSD is a great idea. On the other hand, that's true for PCM as well. With PCM, you're always better off using a higher sample rate if you can, but certainly a wider sample if you can, to do all of your math and everything else. When you get done, you finally dither it back to the right size. So in a hand waving sense, DSD just widens as you edit it. It isn't magically always 1 bit. But when you get done with your thing, you have to narrow it back to 1 bit with a sigma delta modulator, and that's architecturally very similar to using dither. So think of it that way. There's sort of a continuum of designs that's pure PCM, or PCM with some noise shaping, or PCM with noise, other encodings like MULA and stuff that they used to use. And then you get up to SACDs, which is a much faster sample rate, 1 bit, but the noise shaping is critical. What is the most important part of SACDs? Well, I've learned that it's the high sample rate. Clearly, if I use 24 bits at the CD sample rate, it can't be worse than 1 bit. It turns out, though, that 1 bit makes the implementation a lot easier. So to go from DSD to audio with 1 bit is a low-pass filter. That's all you've got to do. You're completely done.
Yeah.
The most direct way to go from PCM to audio is an R2R ladder, because that lets you have exactly the right weight for each bit in a really simple piece of hardware. Reality is vastly different than either of those extremes. Most of the time when you buy SACDs, you've got stuff that was recorded with a thing that's a 5-bit DAC running at a high rate, and then they took the output of that 5, 6, 7-bit DAC and they converted it in one direction to PCM and the other direction to DSD. That's how the DACs in our systems work. You get a little DAC chip, and what it is it's got a sea of little 5, 6, or 7-bit DACs, and it takes whatever's coming in, upsamples it, noise shapes it, and then sends it to those DACs. The reason you do that is it lessens, it makes it easier to build a audio analog low pass filter. With DSD, you can even do it passive like I do.
Yeah.
If you're trying to do the brick wall filter for PCM, you're not doing that analog. I mean, the slope of that is hundreds of dB per octave, which is
and
just
to that point,
can't be done.
Then to that point, Ted, the silliness that I'm seeing now in the industry, they're using those old TDA, was it 1541 chips from Philips? From
Yep.
like 30 freaking years ago when I was in high school, man.
And you know what? Those are the exact technology I'm talking about.
Yeah, yeah.
Noise-shaped PCM, run at a high rate with a narrower things. It's hilarious to me when people talk about NOS DACs sounding better because, you know, they're true PCM. It's like, no, they're not. You know, they're using PCM. The original DSD DAC. So I just got distracted by somebody saying something here.
Sorry, go ahead. I'm not watching the text. Paul's managing that end.
Okay, I just saw David Dass say something, but it went away.
If feel free to whatever chat questions you're comfortable to answer, go for it now.
Yeah, I just usually talk without watching.
Feel free to have a sip if you're feeling thirsty, man.
My apologies. It was actually me. I had chimed in the chat that I recall back in like the late 80s, early 90s, that some CD players came out with 1-bit DACs, but they were usually like low-end CD players because of the time multi-bit DACs, you know, were the thing. So it's funny that DSD eventually went with a 1-bit DAC.
Yeah, there's a reason for it. And it's actually the same reason that DVDAs have, you know, how much information they have on a disc. All of this is how much can you fit on a disc. With CDs, they had a certain physical size and a certain density they could achieve, and they wanted to fit as much as you can. Some people say Beethoven's whatever has to fit on one side. But that basically constrained the sample rate and the number of bits per sample. So they used the most bits per sample and the highest sample rate that would fit on a CD. DVDA is doing the same thing with a DVD, which can hold a lot more. And so you've got room on the DVDA to have a stereo version, a surround version, another edit of the surround version, so on and so forth. And SACDs are very specifically designed to get the same amount of music as a CD in 5 channels as well as in stereo. And they picked the highest sample rate that would work with 1 bit, because even 2 bits, 3 bits, 4 bits, 5 bits would have completely blown up the size of, I mean, SACDs. They couldn't fit on a single DVD. And so I was always, to me, it's interesting that both for CDs and SACDs, the engineering that went in to push the limits as far as they could in order to get a certain amount of sound at a certain quality. And you can't really do a lot better than either of those given the constraints they had.
Cool. Let me go on to question number 5. So I know you and I talked about this beforehand. So for me personally, I kind of compare your DirectStream DAC to like having a Lynn Sondek LP12 turntable from back in the day, right? So there's a lot of us in the club that kind of gave up on vinyl. I sold all my stuff and just focus on a SACD, DSD, PCM formats. And I think you already did a little bit of this, but the whole, what you're doing inside the DirectStream box, and correct me if I screw this up again, that there's a 20x up conversion. If you're like, for example, if you're playing a CD and all that.
You need to be careful to define what 20 times what. And it's
that's why you're going to correct
20
me.
times
Go for it.
the nominal SACD rate, so which is 64 times the CD sample rate. Okay. So this is 20 times 64 times 44.1, which comes out, I might get the wrong number, but approximately 159 megahertz. And I picked that number. Well, originally I picked 10 times. And the reason I picked that is that was the smallest number that I could use an integer to upsample both CDs and DVDAs. So 2496 and 24172, their minimum, their least common multiple is that number I was talking about. And that meant that the math could be simpler and implemented a smaller amount of space to do the upsampling. So since it was possible, I went up that high, and then I would downsample it by 5 or 10 at this point to get to the real DSD outputs. Sorry to interrupt, but
No. That's what I told you that before. And when I screw it up, correct me. No problem. I'm not offended. Trust me. All right. So we talked about that. So the next part of this, do we have Roy Cook and Peter and those guys on? Because I wanted to get their opinions of your DAC that they already own, and if they've got any questions they wanted to ask you or compliments.
This is Pete. I'm on.
There we go.
Let's see. Let me just.
Take your time. Take your time.
Okay. Prior to purchasing or prior to listening to this, the DirectStream DAC, I had a DCS WC, and I really loved that DAC. And then one of our club members had the DirectStream DAC with, I think it was Snowmass firmware. So he was telling me how much he liked it. So I brought my WC over because I thought, I thought a lot about it. So anyway, we put it back to back, and we chatted afterwards, and both he and I both thought that the PS Audio DirectStream DAC bettered the WC in like the clarity, just little, it was less. You could hear little things just more clearly. So that that put me over the edge. And I've been a fan ever since. So what can I say? And then I think the software that I have, Windom, it proved it to me even, whatever, 20-30% more. So I'm a happy customer, happy camper.
I like that.
So I came in late, Ted, so apologize for that. But
no problem.
Were you guys talking about any software updates or no?
Not yet. We haven't talked much about the DirectStream in particular at all yet.
Okay. All right. Well, that's what I have to say. I have not. To be honest with you, I have not done used like the. I haven't got it with the network bridge, and I haven't used that. I haven't used USB input either. I'm just going into it by optical and SPDIF.
Well, I'll jump in on that note.
Okay.
Say something that I always like to say is that with the DirectStream, all of the things that made people pick SPDIF over Toslink aren't necessarily valid. In fact, with the DirectStream, Toslink is the one that has the leg up. It can't have quite the same bandwidth, although for many systems you can do 24/196. But ignoring that, it doesn't have an electrical connection. And if you take jitter out of the equation, which the DS does, then what are the differences? Well, it's how much noise you've got coming down the cable and whether you've introduced ground loops and all that. So a surprising number of people have found in their systems that Toslink sounds better. That's why I used it for my initial demonstration. It sounds fine, and you're interfering with people's systems a lot less if you just show up with your DAC and go with Toslink. So the real differences in all of the inputs are more how they ground things. And you can sort of demonstrate this to yourself if you've got a DirectStream and say the Matrix XSPDIF2 or the PS Audio's DMP, because they have a whole bunch of outputs. They have RCA, XLR, Toslink, and I2S. And if you plug all of those into the DirectStream at the same time and hit play, as you select different inputs, you won't hear any differences at all, or at least almost all of the people I've ever done this experiment with haven't heard any differences at all. What was funny to me is when I showed Paul that, what he was most interested in is you could change inputs without a click or a pop, which was driving them nuts with the perfect wave DAC. So that impressed Paul and PS Audio a lot more than how jitter agnostic the DS was. A lot of people, when they're trying out Toslink, make the mistake of A/Bing it with different inputs on the DAC. That's a problem because then you have the worst of both worlds. You've got all of the noise that's generated by the RCA hooked up while you're listening to the Toslink, and you don't have the bandwidth that you could get with the RCA on the Toslink. So if you are interested in trying Toslink, remember, unplug all the other inputs to the DAC, listen to the Toslink, then plug back in your favorite input, and ideally only that input to the DAC, and listen and compare them. As a matter of convenience, I have all of my inputs full. I don't worry about the little differences you get by having different ground loops, but a lot of people would be surprised that there isn't much difference when all of the things are plugged in, because then they're all sharing the same ground problems. So I want to be clear, I'm not saying that the SPDIF input always sounds better than the I2S or better than USB or whatever. That really depends on your system a lot. But you don't want to think about these things in terms of jitter. You don't want to think about these things in terms of clock separate from the data or anything like that. All, you know, bits are bits at this level of the thing. All the systems can get all the bits there correct and almost on time. So the differences are more where your cables are routed relative to your system, whether or not you're using balanced versus unbalanced, and whether there's a ground loop in your system that might make that noisy, or conversely make an unbalanced cable radiate into your amp or whatever. So one of the points I wanted to stress at the outset that I forgot about is, you know, a lot of people think this is a simple world and there's binary answers to things. And all of us, when we are asked the question directly, know that that's not true. There's no single input that's best for anybody. There's no single way of getting your data, say streaming or off your local hard disk or off of a CD, that's best for everybody. It really depends on their personal preferences, their system, and their biases, and the implementation of these different things. You know, a cable from one manufacturer might sound better than another. You know, your source, if different sources will sound different with a DirectStream. So you really need to listen to yourselves to find out which one's best, and forget about the technical differences in the theoretical technical differences in the cables dealing with jitter. In fact, I'll go one further. I mentioned earlier that DSD is nice and simple because you only need a low pass filter. An R2R DAC is nice and simple because PCM maps directly onto it. You don't need to do anything except clock it well. And everything else is a continuum, and you really don't know what technology is being used in each. Ironically enough, the ring DAC that DCS uses is strikingly similar to the guts of a Wolfson, ESS, etc. They do the same thing. They upsample the data. They send it to a bunch of 5, 6, or 7-bit DACs. And when I say bunch, I mean it literally, because you can't build accurate 5, 6, 7-bit DACs inside a chip. They have like 32 or 128 separate DACs, and they pick them at random to sort of average out the problems in the analog hardware. And that's one of the things that the ring DAC does. So from that point of view, they're using exactly the same technology. So you couldn't just say based on how the bits flow and how, you know, that the DCS is better than a chip. We know it's better than a chip. And the reason it's better than a chip is the same reason the DS is better than a chip. They're discrete. They have gobs of area, so they don't have to worry about having clock lines next to data lines. They don't have to worry about having clock and data next to the analog out. They don't have to worry about having a microscopic amount of current and a very low voltage for the analog out. They can put out whatever voltage they feel like. And they have a lot more space to do math for the upsampling and everything else. So you don't need to take the kind of shortcuts that a lot of these chips take. I mean, a lot of them, in order to do a multiply, they try to find the coefficients close enough that has the least number of ones so they can change it into a multiply. Well, that's constraining your filter when you do that, and it means your sound isn't quite as good if you just had bag it, whatever the theoretical filter number is, I'll use that. So the DS is a lot like the DCS in being discrete and taking advantage of that. And the DCS is a lot like the little chips and everything else in that how it actually does math on the bits and how it uses a multitude of DACs to get the answers out.
Yeah,
so,
it gets convoluted and complicated by the time everything's said and done. Before we get to the club questions that were emailed to you, I got one more question.
Uh-huh.
Remember we talked about my poor man's I2S, those Chinese adapter boards? Now hear me out. There's a lot of us in the club. It's not just your DAC, but then they've got I2S, like DACs with the I2S input. And I keep telling everybody, the only way you're going to be able to play your SACD discs is with an external DAC that's either one of the PS Audios Junior or Senior, or a DAC that has an I2S input and does whatever PCM conversion inside of it. But then I remember when I was talking to you about if those adapter boards that I'm using with my Sony Universal player, again, there's caveats with that because you can only do 2.8 megahertz DSD because of the Sony standard with the HDMI cable. Unlike the PS Audio drive, which will do, well, wait a minute, sorry, I said that wrong. SACD will only do 2.8, but then a lot of the club members, they're only using the USB input so they can play 2.8 and 5.6, but then you can't spin discs with a USB input. So did I go way off the rails on that question, or?
I'm not sure what the question was. Let me take that as a start.
Okay.
A lot of people like I2S because theoretically it sounds better because it has separate data and clock. And 99% of the PCs out there separate the data and clock for the very simple reason is it's efficient. Yeah. When the clock edge goes up, you see what the data is, and then you change the data. Sometimes when the clock edge goes down, and the next time the clock edge goes up, you've got the new data. So in I2S, you're basically doing that. You have the clock, the left-right channel, and the bit, and the clock set like that. Ironically, at both ends of the spectrum, people tend to encode things differently. They use a single wire, and they encode the clock and data together. They do this if you have a wire that's miles and miles long because it's cheaper to run one wire than 24 or whatever you want. And with very dense things like GPUs or a whole bunch of FPGAs on the same thing, they're talking to each other at 10 or 20 gigahertz. They encode the data on the wires just so that they only need to run one wire from here to there, not 2, 3, 4, 5, whatever. So as I mentioned earlier, people like I2S because of that theoretical advantage. I also mentioned that doesn't really matter on the DS. It's other things. But the I2S cable has one other feature, is it's balanced. All the signals that are going over the cable are being carried by a cable that was designed to carry high speed data with balanced pairs.
Mm-hmm.
And so it's almost as if they designed the HDMI cable for doing I2S.
Yeah.
Now let's jump tracks just a little bit.
Go for it.
DRM is the thing that confuses all of this stuff when you're trying to talk about what boards you can hook up and everything else.
Yeah.
Both for SACDs and for DVDA and all higher res PCM, Warner and all the other music companies wouldn't let them ship it out if there's a way that the customer could rip it.
Right.
That was extremely important to them, that they not let the high resolution versions of things get out. So DVDA chose to use watermarking to validate that, and SACDs chose to use pit width modulation on the DVDs, so they actually encrypt the data. What's ironic is the only way to, DVDA was broken almost immediately within like 6 months.
Yeah.
But the SACD still hasn't been broken. But Sony did build some other hardware that knew how to read SACDs and let people have it.
And again, that's I tried not to go off the rails on the question, and as usual, I did. So remember I was telling you I've got the Sony Universal player, and it plugs into my Sony receiver, and it does the whole DSD chain that. I mean the DACs suck. I agreed, right? But
yeah,
the only way that any of us can play SACDs is through the I2S, whether it's the output of the. Again, this is just disks, not actual files on your computer.
It depends on what you're using to play the discs.
Okay.
The PS Audio DMP lets you play SACD over any of the interfaces.
Right. Whereas mine doesn't. Mine will only.
To honor the SACD licensing, they don't let the raw bits show out where somebody can just rip them.
Understood.
They do a handshake to make sure the system's put together. That's exactly what happens inside an HDMI cable. HDMI 1.0, 1.1, 1.2 didn't support DSD. 1.3 put it in the spec, but I don't think there were very many systems that actually supported it.
Yeah.
But at a certain point, all the little chips you might buy to do HDMI for you and do the decoding, everything supported SACD, and it supported it over an encrypted setup. Now, the way these little cards work is they're illegal in the United States.
Yeah.
They are letting the DSD bits out.
It's all good.
I don't know how they don't get caught, except for right now, I know Sony doesn't even know they invented SACD for 99% of their employees. So they're not really going around chasing people. Yeah. And the Warner and all the music companies don't realize what's going on at that technical level, so they're not pushing the issue either. One thing you've got to do, if you have a DS, when you're using one of these things, you need to look at the screen and see if it says DSD.
Mine does.
Or DOP.
Nope.
Yeah, what I'm getting at, though, is many people get one of these de-embedders for an HDMI cable, and they think they're getting out DSD. They're not. When you can't do the handshake, vice versa, everything dumbs it down. So your SACD player will dumb it down to 2488.2.
Right.
Or your DVDA player will dumb it down to 48K or 96K. So a lot of people are surprised that they see 96K on their screen. They think that's what the source is. No, most of the time it's not.
That's right.
They're just getting something to translate it for DRM purposes. So when the box is illegal, they can do whatever they want, right? They just don't honor the.
Guilty is charged over here. But again, when we had our conversations before, I see the whole, instead of DOP and all this, it actually says 64-bit. Sorry, 1-bit 64 FS when I play an SACD disc. But again, yeah. I get your point 100%. That's, all right. We'll get out of that topic now. But again, you and I talked about this on the phone. All right, so bear with me. Okay, so we've got no other DS owners here that want to ask or compliment or say anything to Ted right now? Because then I'm going to take it over to the pre-screen questions. I don't see anybody else. So Ben Taylor's not on either, Paul?
No,
I'm here.
Is he there?
Yeah, I
Okay,
just look
actually,
terrible
let's
today.
move it over to Ben because there's a bunch of stuff that he
Well,
wants to talk about. He's our recording engineer for the club.
well, yeah, kind of.
He's our man.
Anyway, Ted, I have a Tascam device which claims to record DSD. It's called a RADA1000 HD.
That's a nice unit.
Does it actually record DSD? I've never quite, I think I've used it once to do that.
I'll tell you, I've done this multiple times. I've taken such a unit to the house of somebody that believes that vinyl is the only good thing.
Mm-hmm.
And if you just record the needle drop with that and then play it right back out on the DS, it sounds so stinking identical to the analog, people get confused. So it's a credible DSD recorder. I mean, there are things that cost a lot more that do a better job, but that's one of the cheapest things, at least 5 or 10 years ago, that did a good job on the DSD. And I like all the needle drops I've done with it.
Okay, I wasn't sure, you know, I never know what seems to be BS with these manufacturers who put stuff out there, you know, and it's not DSD over PCM or something, or so.
Yeah.
Hey, Ben.
Yeah.
Hey, Ben, this is Pete. And Ted, how about that Korg portable unit that you have it and I have it as well, the MR1000?
Oh yeah, the 1000, MS1000?
Yeah.
That's supposed to record DSD as well. Are you familiar with that, Ted?
I haven't used one, but yes, it does it, and it just came later than the Tascam. And I've talked myself out of purchasing it 3 or 4 times just because I've got too much to do to.
I understand. Yeah.
But it's a cute unit. I would really like one.
You know, when we had a club recording session at the Musicians Union Hall, Ben, you recall, I recorded using your MR1000, and I'll tell you, I really loved the sound that made compared to my PCM 2496 recording of the exact same, using the same mics and the same mic preamp.
Yeah,
So, that's my take.
I've gone multiple times to live sessions where they're recording with DSD and then playing it back in the other room, and you can just walk back and forth and hear it live or hear it over DSD. And if you close your eyes and aren't disturbed by some of the room cues or whatever, you hear the exact same thing either way. It's amazingly lifelike. It's as an amazing experience as the first time I heard 32 IPS tape masters. You know, just amazing to hear that quality. By the time it gets out to us on a disc, just like CDs, a lot's lost. But you know, the fundamental
playing it back and then comparing it to the live, you know, you now have speakers and an amplifier and other stuff to deal with, right?
You do,
not
but
to mention the microphone. So
but my point was these were great systems that they did this on, right?
Okay.
At Gus Skinnis's mastering studio, for example, you know, he's got those same vastly expensive Sony speakers and excellent amps. I don't remember who's using right now, but yeah, if you had it on a lesser system, I'm not going to say it sounds live if you play it on your, you know, or even on the DS. I don't know if it would sound live.
It'd be difficult for any of us to do anyway, because we wouldn't have access to the live source and then the playback source, you know, so.
But you know, it really does say that recording with DS is not a horrible idea. I mean, with DSD is not a horrible idea.
What about some have claimed that it's a little noisier a system, even though it may have a more real sound to it. Is there some noise involved there, which I don't it doesn't matter to me because we can always work that out.
There's multiple ways to come at this. The noise that's there, indeed, DSD does have noise, ultrasonic noise, and you have to filter it out. And there's a balance. You can put in a really sharp filter and lose the magic of DSD. Or if you put on no filter or a really shallow filter, you can blow up people's amps. And it literally, the first SCD1 that Sony put out for their original SACD player blew up a couple of people's amps. So they put a little switch in it to switch it in a 50 kilohertz filter so that they wouldn't blow up their amps. Now, on the DS, we cheat a little bit. We let a little more ultrasonic noise through. In fact, we took off one of the levels of passive filtering on all of the boards that are out there because it sounds better. All of our customers agree. So we're letting more ultrasonic noise out than we should, but it sounds better. The thing is that the ear is excellent at hearing low-level details that aren't harmonically related to the input. You know,
It's 8 o'clock.
if you have, you know, I don't know, you know, any kind of distortion that's coming from digital stuff around or whatever, the ear picks it out right away. But when it's harmonically related to the input or completely random, the ear just throws it away.
Ignores it, yeah.
And so that noise that's coming from the DS is not heard by most. It's also at a level that's lower than the signal to noise you get off of a CD player.
That's what I
So
thought, yeah.
it isn't that high. Now, there's a lot of people that want to go without a preamp. And then you have a level matching problem. If you're going straight to your speakers, you know, every good recording engineer knows how, for each stage of their system, to get the levels normalized so that they're not overflowing and they're using all the bandwidth they've got or all the bits they've got. Most consumer audio people don't really understand this concept. And if you're trying to get by without a preamp, the DS accommodates you a little bit in that it has a 20 dB attenuator that's done analog. So when it attenuates the signal by 20 dB, it also attenuates the noise by 20 dB. When you have the system level master your speakers, you don't hear the noise, except maybe perhaps if your ear's right up against the speaker. And I've listened to the same hardware that they were used to record like 90% of all the early SACDs, the stuff from Meitner. I have a Meitner DAC system.
Right.
It produces a little more noise than the DS, and you don't hear people complaining about that. So it's some, I don't want to use the word pejoratively, but some propeller heads really are upset by the idea of noise, and I'm not going to argue with them. I don't use vinyl because I'm upset at the idea of every time you play it, it gets worse. Now, a lot of vinyl people will tell me I'm crazy, and that's fine, but that's why I'd rather use digital. It's not that it sounds a lot worse or whatever, but you know, I think you're missing out something if you don't use DSD because of the theoretical noise level.
Well, I didn't do it because of that. It just was a hassle to do. And if I had to send files somewhere, chances are the person I sent it to didn't have the ability to download those or to decode them. And I don't know, it just became a problem, another problem that had nothing to do with the quality.
Right.
Yeah.
Yeah,
if I was doing a record, that's different. If I'm working on a record project, of course, no problem, recording DSD because I'm the one that's going to deal with it, so.
Yeah, I wasn't speaking to you specifically on that.
Oh, I understand. I'm just
Okay.
making a comment, yeah.
Hey, and one other thing about recording with DSD is that when you're editing it, you've got to go back and forth to PCM, which to me is.
No, you don't.
You don't?
That's what I said earlier.
Oh,
If you treat your DSD, A to D, and DAC like a tape machine, then you play it, go into your analog mixing console or whatever, and then go back out and record it again. That actually sounds just as good as the recordings that are done that way back in the 40s and 50s. Multiple
If you're
passes
editing,
through.
but if you're editing, don't you have to have an editor that will handle DSD?
Well, I'm trying to talk about an alternative way of doing it that doesn't work for a lot of people, but it's the best way to get the best sound.
Okay.
And that's what like Gus and Cookie Marinko and other people do is if they need to edit, they play it and then it's analog and they do whatever analog thing they want and then they record it again. And arguably the generation loss, if you do that at 64 FS isn't horrible, but it's not great. But as soon as you go to 128 or 256 FS and do that, you'd have to re-record like thousands of times to add enough noise that you notice it. So the only real noise you're getting is from your analog hardware and your A to D and D to A. Now, you can edit DSD directly. Most people don't give you editors that do that because it costs a lot of resources. If you take a DSD signal and multiply it by 2, now it's 2 bits wide everywhere, but it has the same information. It will sound the same if you had a piece of hardware that would play the 2 bits. You can do all the editing you want and let it go up to 24 or 32 bits wide or whatever you want at the original sample rate. And then when you're all done, run it through a Sigma Delta modulator back to 1 bit, and it will be, as good as PCM after you've done the editing and done dither. But it takes so much horsepower to do that, at least in the past, and it took so much disk space to hold the intermediate results, at least in the past, that nobody would do that. I'm a little surprised that nobody's done it, and I've had a lot of people come and ask me to do it, like Sony and Dr. Demery and David Kawakami. But that's not my real passion, is writing that editing software. I've done that in the past and I know what it's like. So a lot of the systems right now do one of 2 things. The Sony Sonoma systems let it grow up to 8 bits and then they remodulate it down to 1 bit. So their editor lets you do, everything you want, but they take anytime the intermediate results get too wide, they fold it back down again. And then there's the way that Pyramix originally did it, which is they converted, anytime you did an edit, they converted it to 24.356.8, did the PCM edits, and then converted it back. If you only do that conversion once and then you keep it in the PCM until you're all done and then convert it back, it's not horrible, but it's not transparent. When Gus was mastering Tubular Bells, out on the second side in the hornpipe, there's a little section that wasn't right, and so they just took a chance and edited it with a Pyramix system, and it basically just went to 24, or actually 32.352.8 for 20 milliseconds. But still, when Gus plays it, you can hear the difference if you're looking for it. So it's not transparent even in little bitty bits, but it's not horrible.
Hey, Ted, so you're cool on time right now?
Yeah.
If you need to take a break, my friend, go for it.
I'm fine right now. Thank you very much.
I'm going to say one quick thing. I promise I'll make it quick. Your point on the whole, the vinyl stuff, and I think I talked to you about this on the phone, the electrostatic headphones and all that I have. I had a little joke with the PS Audio forums where I play Abbey Road and the Giles Martin mix. And when I Want You ends and all the John Lennon screaming and the loud guitars, it's like absolute dead silence, right? And then Here Comes the Sun starts. And I was joking with the guys on the forum, all you vinyl guys have to get up, flip the LP over, put the needle down, and you lose that whole effect.
But
That's
just
me.
playing
though.
the
That's
devil's
just me.
advocate, that's part of the experience for a lot of people. And that actually enhances the experience. Just like having the album cover right in front of them while they're playing is part of the experience. I actually enjoy things that way too. That getting up and doing that doesn't bother me when I'm doing vinyl. Just like if your music's any good and your recording's reasonably clean, you don't ever hear ticks and pops when you're playing vinyl. If they're
Ignore it.
there,
Yeah.
they don't impinge upon your conscience. They don't matter at all. On the other hand, if you're a digital diehard, every one of those ticks and pops drives you nuts.
You gotta remember, I used to be a vinyl guy. I was telling you before, I ripped all my stuff onto my server, you know. And again, the whole thing with your DAC, a lot of the little nastiness that I had in those PCM transfers, it cleaned it up.
Yep.
I don't know what magic you did inside. We already talked about all that stuff, but
well, I already mentioned the magic to some extent.
yes.
Just like DCS, I have an FPGA and I can do accurate math rather than the shortcuts that are in the chip. That's a big part of it in reality, is doing good filter well. And, you know, I don't care about how many bits are in my numbers. I just use them as they come out of my software. So I actually use like 34-bit coefficients on 28-bit data into 50-bit intermediate results for all of the filters.
Yeah.
And then when it's all done, you know, I send that wide word through the volume control, and I send the wide result of that out to the modulator. So I have a really wide modulator. It's at times like 67 bits or something wide, just so that I don't lose anything with any bit that's coming in. So anything that changes on the original CD, any bit, has the correct change in the output, plus or minus noise. But, you know, it goes through all the digital stuff, in essence, perfectly.
Cool. So my next part was the pre-screen questions that we had. I was going to start with Keith McDonald's question that he sent this morning.
Okay.
There was a big long one. I don't have it in front of me, of course.
I do.
Okay, cool. Much appreciated. I'll let you dissect that to, you know, as you wish.
In the first part, I'm not going to read it literally, but he's basically saying separate clock and data don't necessarily, as being an advantage of I squared S, doesn't necessarily sound like the best way to do it for him because of issues like clock skew, noise on the lines, and other things that can corrupt the data. Well, first off, you know, computers work. They, you know, anytime they do corrupt the data, they can figure it out and get the real data in time. And 99% of people's DACs work. The audio is corruption free, you know, digitally corruption free. You hardly ever get bit errors. Some of the old CD players had a light that would light up anytime you got an error, and they just like never show up except on, you know, badly scratched discs or whatever. But still, in theory, a separate clock is better because it tells you exactly when the data is going to change and exactly when you should look at it, and it's still. So the clock says, here is the best place in the world to see what the data is. And the opposite side of the clock says, change now so you'll get it right later. There's another way of doing it that's a little more complicated, which is you change the clock, you change the data and clock simultaneously, and that's more used inside components, but that's not the issue. But encoding the data and clock isn't necessarily bad either. It can save you wires. But when you start taking noise into account, you can have some differences. Just like a balanced XLR connection can sound better than an RCA connection, and that's at least with the DS, it's not related to jitter at all. It's just got to do with ground loops and how much radiation is going out. of the wires to affect the rest of your system, and how much the radiation in your system is bothering your system because of the ground loops. So using balance lets you get by all the, well, not all, but all the common mode noise issues. Similarly, the HDMI cables that are used for I2S for the PS Audio stuff are balanced. And so you can run fantastically long cables and everything will be just fine. Did I get your answer the way you wanted, Keith?
Yeah, Keith is on, I believe. Keith, you're there?
We've got you captive here, Ted. What is your definition of a true balanced circuit with a device that's supposedly also balanced in the path? How do you, are differential amplifiers truly balanced, or is there some kind of hodgepodge going on there?
If you put another word in there and you distinguish between differential, which doesn't specify where the ground reference is,
right,
and symmetrical, which says it's got to be symmetrical around something, which is the ground reference.
right.
Differential, when implemented properly, works just fine. It's hard to implement properly if the grounds of your system start spreading apart. So, if you're plugged in here and somebody's plugged in an outlet that's, 100 feet away, there's going to be a differential. Sometimes that differential can get up to like 10 volts. When your ground differential is 10 volts, the receiving circuitry probably doesn't have enough headroom to deal with that relative to the ground, right? So by tying the grounds together in symmetrical, you can allow a cheaper implementation of the receiver circuit. The whole DS is symmetrical inside, just because even at the digital stage, I'm using differential data, and as it goes through the analog, it stays differential, and it'd actually be harder for me to make it single-ended than just to take the balance things out. And differential has the advantage of, in theory at least, getting rid of all your even order harmonics. At least the distortion for your even order harmonics. So I very carefully use one differential block this way, and then the next this way, and then the next this way, and then so that whenever any signal is going up, some signal is going down, that's differential. I encode the balance signal with differential cables, with differential signals, so that to get the one side of the balance, a differential cable, a differential connection says where it's at, and to get the other half of the balance, another differential signal says where it's at. And to do that, you have to have 4 things driving. And then finally at the output, when it goes through the transformer, it gets set up to either be just purely differential or symmetric, depending on whether you use the center tap.